Today we are continuing 1.3 notes, the notes that we started yesterday. Yesterday we went through our first 2 pages of our notes, and we ended with 1B, part B. So today we are going to continue with question 2, where it says, suppose each student raises $10 from a sponsor. How many kilometers does each student walk? Well, now that they told us that each student raised $10 from a sponsor, we can determine how far they walked. So we can figure out Elena's by plugging in her equation that we created. Can someone tell me, Anthony Coleman, can you tell me the equation that we created for Elena?
I said, I don't know.
Well, look on the front page. Where is it? On page, question 3 on the second page. We made an equation for Elena. What was that equation? We're just doing a little bit of a review from yesterday, too.
It was
P equals
5 plus 0.50.
Oh, it was K? Okay. So we have P equals 0.5K plus 5. That's the equation we came up with. Thank you. So now if they said the students raised $10, Anthony, where should I put that in this equation to calculate the distance?
I put it as like for the P
Mhm.
equals 5
Yep.
plus 5 0.50 times 10.
Okay, so our P is what they, let me see right here, the total pledge amount, the amount they made. So if they said that they raised $10, let's plug our 10 in for our P. Now I can simplify because K means the kilometers, which is our distance. And that's what we want to find for Elena. So I can calculate using this equation. Elena's distance would be 10 kilometers. And then if we go on with Gilberto, his equation that we found was 2K. So if we plug 10 in for P, Gilberto's distance would be 5K, 5 kilometers. See how we're taking their equations and plugging this 10 that they raised in for their P? And then for this one, it's not available. Because we don't, this is our explanation for it. This is for Leanne. We don't know because she gets $10 regardless. The distance doesn't matter. We don't know the distance because we don't even care about her distance because we know how much money she's getting. Whether she walks 1 kilometer or whether she walks 50 kilometers. She's still getting $10 from each sponsor. So on 30 it says, on which graph does the point 10 or 12, 11 lie? What information does this point represent? So that point, 12, 11. If we go back to that second page where we created our graph, either Elena, Gilberto, or Leanne, one of their lines goes through 12, 11. That's all they're saying is which person does. So with your shoulder partners for 1 minute, look back to that graph that we created and see who goes through 12, 11. Who would? You might have to extend your graph a little bit to get there because I think we only went until like 8 or 10 and they're asking for 12. So just extend it based on the pattern. About 1 minute. All right, everyone come back together. Eyes are up here. Joey, can you share with us which person? Elena? And why do you say that? Okay, so you looked at your graph and you matched up 12 because you know 12 is your x-axis and 11, which is your y-axis, and you were able to determine whose point that lies. Okay, so Joey, based on what you told us, I can state that this tells us that if she walks 12 kilometers, she'll earn $11. So if I go back a page, right here, this is my, if I walk 12 kilometers, well, if I briefly go back to this chart, I know we recreated this yesterday, but if I go over here to my 12, and then over here we did $2, 4, 6, 8, right? This is what your table looks like. 12. So basically they're saying, like, right over here, that's what we're explaining, that when we look at the table at distance for 12, it can go all the way up to 12, and $11 right here, that point, where does that point lie? Well, Joey told me that that lied on Elena's graph. Blake, question?
Why is 12 on there twice?
12 on where twice? Oh, this is my sloppy dollar sign. So $2. Okay, so that's basically what we're looking at in the graph to determine that. If we were to go on to part C now, it says Gilberto decides to give a t-shirt to each of his sponsors. Each shirt cost him $4.75. One shirt costs $4.75. He plans to pay for each shirt with some of the money he raises from each sponsor. Write an equation that represents the amount of money Gilberto raises from each sponsor after he has paid for the t-shirts. Explain what information each number and variable represents. Blake, did you have a question?
What about 4? What about each part being 4?
Did I skip a part? Oh, I did. Okay. Thank you. Lily, is that what you were going to say too? Okay. I'm sorry. I completely skipped this part. For 4, it says in Elena's plan, how is the fixed $5 donation represented in a table, a graph, and an equation? So, let's do this with your shoulder partners. It says in Elena's plan, so you're only going to be looking at Elena. And at $5 donation, how can you determine that based on looking at the table that we created yesterday, the graph that we created yesterday, and we also created an equation. So I will let you know that in the table that was on our first page, it says a fixed $5. Well, if I look at the table and I look at where Elena's $5 is, I can see, right? Let's look at the table together. That is at 0 kilometers. So I can share that this amount she gets before even walking. And I know this is before walking because it says she's at 0 kilometers, which means she hasn't even started. If it was at like 1 kilometer, then yeah, she would have walked 1 kilometer already. But we're at 0. So I want you to do the same thing with your shoulder partners for the graph and the equation to help us determine. I'll give you about 2 minutes. Let's come back together and let's look at the graph part first. So Sam, can you share with us how you were able to see that the fixed $5 donation, how it was represented for the graph? How were you able to determine that, where the fixed $5 was? Yeah. Yeah, do you want to help her out? Okay, so what's that point, though, that we're going to be looking at to see that? 0.5, yeah. That's the key part of it. That this is shown, whoops. This is shown at 0.5. When she walked 0 kilometers, she made that $5. That's that fixed $5 that they were asking. And now with the equation, let's do the same thing with our equation. Elena, how are we able to determine this based on the equation? Is there a fixed $5 in the equation somewhere that we created? Tell me the equation first. Let's write it on the board.
Equals 0.5k plus 5.
Plus 5. Okay, that's the equation for Elena. That's the equation we're going to be looking at. So now, is there a fixed $5 that we can clearly see in this equation, Alana? Yeah? Where is it? This added 5. This is the 50 cents. So the $5 is added to the pledge. Pledge of the 0.5K. It's added to that 0.5K. So that's like our B in our equation. So now if we go on to see where I was reading before, it says, write an equation that represents the amount of money Gilberto raised from each sponsor after he paid for the t-shirts. Explain what information each number and variable represents. So now we want to create a new equation for the t-shirts because he told us that each shirt costs $4.75 and he plans to pay for each shirt with some of the money he raised from each sponsor. So let's start by stating Gilberto's equation that we already created, Lily.
P equals 2K.
Okay, perfect. P equals 2K is his original equation. And then they said he's going to take the profit from this equation that we calculate, and he's going to take some money out of it to pay for those shirts. Well, how much did he say his one shirt was, Gavin? $4.75. So can we include that in this equation somewhere? How can we include that in this equation? They said that they took this equation and he took money out of it. He took $4.75 out of that total.
Right, $4.75.
Exactly. I can subtract $4.75 from it to find the real total after he spends his money on his shirt. So if we were to break apart what each thing represents here, our 2K is the money he gets. The $4.75 is the cost of the shirt. So in 2, it says graph the equation for distances from 0 to 5 kilometers. Compare this graph to the graph of Gilberto's pledge plan in question A. So that's that plan on the second page. So it says we want to find the money. I'm going to make my table here. My distance is on the bottom. I'm going to go by 2. So 2, 4, 6, 8, 10. And then let's start here. We'll make that a -6, -4, -2. Then we have 0, 2, 4, and 6. So there's our numbers for the amount of money. Did everyone include this in their money? So what is my y-intercept based on the equation we just created with Gavin, Phillip? What is my y-intercept? Where am I going to plot that point first? Based on the equation that Gavin helped us answer right here. 0 what? Our x-axis is going to be 0, and what's my y-axis going to be? Let's look at our equation again. We have y equals mx plus b, or in this case, y equals mx minus b. So what's my y-intercept represent in those kind of equations? Is it the m, the x, or the b? My y-intercept, where it crosses the y? Brayden, do you want to help him out? If I have this equation, let's break it apart. What's my m represent? My slope. That's my slope. And this is our actual x variable, and this is my y variable. But do you remember what this b represents? What does that b usually stand for? Maria, do you want to try it?
The y-axis.
The y-axis. That's where it crosses the y-axis when the x is 0. So since this is our b, we're going to go right here to like just below it at 475 because it's a negative $4.75. So that's where we're going to start. And then what is my slope based on that new equation that we just created, Anthony Morisi? I'm sorry? 2, yeah, because here's my slope. It's the m. My m is the slope, and here's my m. So I'm going to go up 2 and over 1 to create this line. So if I go 1, 2, go 1, 2, it's going to be something like so. And then if I create okay, there's my line. That's all they said to do. Based on the equation we just created, make a line. And is this a relationship linear? Is this relationship linear here? Robert?
Yes.
Yes. It is linear. Robert, why did you say so?
Because it goes up at a constant rate.
It goes up at a constant rate of change. What else can we determine based on looking at this graph? Is there anything else? I can see 2 things maybe. When we have a linear line, a linear graph, what does that line really look like, Robert? It's always a straight line, okay. And then I was going through this with Braden and Philip. When we have an equation that has a linear relationship, what does that equation really look like usually? What type of equation are we expecting when we have a linear line? What equation are we expecting, Blake? Y equals mx plus b. So to determine whether this linear relationship is true or not, if it is one, there's 3 different ways we can determine that. Is there a constant rate of change? Yes, it's going up by 2s. Is it a straight line? Yes. Is this equation in some type of form of y equals mx plus b? Yes. Well, since it's yes to all 3 of those statements, then it definitely is a linear relationship. So if we go on to our summary now, let me see what your summary says. All right, so in your summary, it says a linear relationship has a constant rate of change and can be represented as the graph of a straight line. How can you determine if a relationship is linear from a table, a graph, or an equation? Well, when you're looking at the table, as the independent variable increases by a constant amount, the dependent variable increases by a constant amount. They're both increasing by a constant. When you're looking at a graph, we just saw that they are straight lines. And looking at the equation, it can be written in the form of y equals mx plus b. So, now that we finished our 1.3 notes, we have a homework assignment that will be due on Monday. Well, here's our summary that I just all read to you. And here's our homework, page 18, numbers 6, 7, 8, and 9. Second. All right. So you'll have the rest of the hour to do that.